Hello, Algebra 2. Great to see you today, or hear from you, or talk to you today. Today's lesson is going to be nice and short. It's on the quadratic formula, which I'm sure you remember from Algebra 1. There's even like a song or something to remember it. I won't sing that for you today, though, don't worry. And the quadratic formula is a certain equation that we can use to solve a quadratic equation. And to solve a quadratic equation, you're trying to figure out these values for x, and these x values correspond to the x-intercepts of a parabola. Like if we were to graph this quadratic equation on a graph, it would cross the x-axis twice because it's a U shape, so we'd have something like this. That's our coordinate plane, and then our quadratic would cross the x-axis twice. And so when we're solving these for x, we're trying to find those two x-intercepts, the two places where the parabola would cross the x-axis. And so to do this, we sometimes get nice, easy numbers, but not always. And so there are different techniques we're going to be learning about to solve a quadratic equation, and they don't always work if they're not nice numbers, crazy fractions, decimals, irrational numbers, even imaginary numbers don't work for some of the other techniques that we're going to be learning. But the one technique that works 100% of the time is the quadratic formula. And so that's why I say here that every single quadratic equation can be solved with the quadratic formula. So it is like the end all be all best way to solve it. The only issue with it is that it does take quite a few steps. I mean, you see this formula here. It does look kind of scary and intimidating at first, but I promise you it's not that bad. And so you'll see in this formula, there are three letters, three variables. B gets used twice, A is used twice, and then C is used once. And so to use this quadratic formula, you just need to plug in the numbers for A, B, and C. Now, where does A, B, and C come from? Well, that's easy. It's just coming from our quadratic equation written in standard form. And if you remember standard form, I've got that written down here. It's probably a form you might recall from back in Algebra 2, or Algebra 1, excuse me, written as ax squared plus bx plus c. And so to find a, b, and c, you're just taking the coefficients of the x squared term for a, the coefficient of the x term for b, and then the constant number is going to be c. So let's go ahead and try identifying these three and then just plugging them in to this quadratic formula and getting our answers for x to find those x-intercepts. All right, so here's our first example. X squared minus 9x plus 14 equals 0. And you'll notice that I've put the quadratic formula up here for you to kind of help remind you. And so I first want to identify a, b, and c. And so looking at this equation, is it written in standard form? Well, yes, it is. Ax squared plus bx plus c. We're good to go. So I need to identify a, b, and c. So what does a equal? What does b equal? And what does c equal? Once you identify those from that equation, you don't even need this equation anymore. We're done with it. I just need to know a, b, and c. And so a is the number in front of the x squared term. And so here's x squared. What number's in front of it? Well, there'd be an invisible 1. So a is 1. B is whatever is written in front of the x term. Now, it looks like it's a 9, but if there's a different sign in front of the number, you have to bring that along with it. So this isn't just a 9, it's a negative 9 because it's a negative 9x. And finally, c is the constant by itself, and we see that there's a plus sign in front of it, so it's a positive 14. So we've got a, b, and c. And now for the quadratic formula, we write x is equal to, and we start off with a negative b. If we're looking up here in the formula, negative b, and that just means whatever b is, you're going to make it negative. And since b for us is already a negative 9, it's like we're going to have a negative negative 9, and so that's going to turn into a positive 9, right? Because the two negatives cancel out. Plus or minus the square root of b squared. Now, when you write this b, put it in parentheses and then square it to make sure that we're squaring the negative as well as the 9. And then after that, it's a minus 4 times a, and a is 1, times c, which is 14. And then all of this is being divided by 2 times a, which is 1. So right there is the most difficult part of the quadratic formula, just plugging things in the correct spots. And it really shouldn't be that difficult, right? We all can match up things pretty well at this point in our lives. And so that's all the numbers plugged in. Now we just simplify. So x equals 9, nothing I can do with the 9 yet, plus or minus the square root. Well, I can do some things in the square root. So first there's that negative 9 squared, and negative 9 times a negative 9 is a positive 81. Minus, then I have 4 times 1, which is 4, times 14. So 4 times 14 is 56. And all of this is being divided by 2 times 1, which is just 2. Okay, so be honest. That wasn't that bad so far. I think 4 times 14 was the most difficult part. If you have a calculator, I bet that was pretty easy. All right, let's keep going. X equals 9 plus or minus the square root of, let's see, 81 minus 56 is, I believe, 25. And do we know the square root of 25? Sure, that's just 5. So we get 9 plus or minus 5 divided by 2. Okay, at this point, we have to deal with this plus or minus sign. Now, if you recall from our polynomial unit and just think about PEMDAS, this numerator is technically in parentheses, meaning I have to add the 5 or subtract the 5 first before we divide by 2, which is nice because 9 divided by 2 is going to, be a decimal. We don't want that. And so at this point, we're basically going to get two different problems. And so, which that makes sense because remember our parabola, it's going to have two different x-intercepts, right? It's going to have an intercept there and an intercept there. So we should get two numbers. Typically, we're going to get two answers. And to figure these two different versions out, I'm going to split this equation up by first doing the 9 plus 5. So I'm going to write that over here. 9 plus 5 divided by 2. And then after we do that, then we're going to figure out the other version by subtracting those. So we're going to then take 9 minus 5 divided by 2. So that plus minus symbol is just a shorthand way of reminding you, hey, you're going to add these one time, then you're going to subtract them a different time. So when we add them, 9 plus 5 is 14 divided by 2 gives us 7. 9 minus 5 is 4 divided by 2, and that equals 2. And so right here, these two values, 7 and 2, are our two solutions. X equals 7 and 2. And if we were to graph this on the coordinate plane, basically that means at 2 and positive 7 on the x-axis, that's where the parabola would cross over. And so that's why 7 and 2 are our solutions to this quadratic equation. You did it. You solved it. Congratulations. Now, this one worked out really nicely. We've got a 7 and a 2, real numbers, whole numbers. That was like the best case scenario. Unfortunately, this is algebra 2, meaning we're not always going to get nice numbers because we deal more with things in the real world, and in the real world, things don't always work out. So sometimes we're going to get irrational numbers. And that's basically when you get a square root that doesn't simplify any further. Think about our radicals from the last unit. And if that's the case, then, the problem's actually going to take fewer steps because I don't have to do that final add and subtraction because I can't, add the square root of 5 to some other number. So let's look at this example too. 6x squared plus 5 equals 6 plus 2x. And so we need to identify a, b, and c for our quadratic formula up here, except I don't really know what b and c are quite yet because it's not written in standard form. All right, so we always want to make sure that our quadratic equation is set equal to 0, meaning just move everything over to one side. So I'm going to bring it all over to the left. So I'm going to subtract 6 from both sides, so those cancel out. Then I'm going to subtract the 2x. I don't have any like terms on the left, so that's just going to be a negative 2x on the left. So when we rewrite this, we're going to have the 6x squared minus 2x, and then 5 minus 6 is negative 1, and this is equal to 0. So now we can easily identify a, b, and c for our quadratic formula, right? So 6 is a, negative 2 is b, and negative 1 is c. So let's just plug these in. X equals negative b. So it's a negative of whatever b is. I'm going to show you those steps here. So it's a negative, but b is a negative 2. So obviously that's going to change in our next step, a negative of a negative 2. Plus or minus the square root of b squared. So we're using b again, which is a negative 2 squared, minus 4 times a, which is 6, times c, which is negative 1. And all of this is divided by 2 times a. And a, again, was a 6, positive 6. All right, so that right there is all the numbers plugged into the quadratic formula. And now it's just some basic simplification. Here we go. X equals, so I've got a negative of a negative 2, which turns it into a positive 2. Plus or minus the square root. Negative 2 squared is 4. Now here I have to be a little careful. I'm subtracting a 4 times a 6 times a negative 1. So count up those negative signs, because I'm going to multiply all these together. And if I multiply a negative times another negative, that's going to turn into a positive. So this is an area where a lot of students get confused with all those negatives. And so I always think that it's best just to look through the 3 numbers that are being multiplied and think about what sign you'd get and just write the sign down. So negative times a negative is a positive, so I'm writing a plus. Now ignore the signs and just multiply those numbers together. So 4 times 6 is 24, times 1 is still 24. All of this is being divided by 2 times 6, which is just 12. All right, so inside that radical, I've got x equals 2 plus or minus the square root of 28 divided by 12. And so the square root of 28, let's do a little sidebar over here, a refresher from Unit 4. 28 is not a perfect square, so we're going to break it down. That's the square root of 4 times the square root of 7, because 4 times 7 is 28, and the square root of 4 is 2. So this turns into just 2 root 7. So we're going to write this as 2 plus or minus 2 root 7 over 12. Now, on the previous example, at this point, we would separate it into 2 problems, one where we're adding and another one where we're subtracting those 2 terms up top, but I can't combine a 2 with a 2 root 7, which actually makes this easier for us because we can kind of leave our final answer in this form. The only thing that you need to look out for, at this point, we've got 3 terms. There are 2 terms up top and 1 term at the bottom. And we still want to simplify our final answer if we can. And looking at 2, 2, and 12, is there a number that all 3 of those could be divided by? Yes, they can all be divided by 2. And so to simplify this completely, for our final answer, we would say x equals, well, 2 divided by 2 is 1, plus or minus, again, 2 divided by 2 is 1 again, so it's 1 times root 7, which we would just write as root 7. And then in the denominator, 12 divided by 2 is 6. So this actually is our final answer. And I know it looks crazy, but it's actually a bit easier this way because you don't have to do that final addition and division because we can't, because this is an irrational number. This right here, the square root of 7 is irrational. It'd be a decimal that goes on forever and doesn't repeat, which we can't deal with. So you just leave your answer like this, 1 plus or minus root 7, all divided by 6. Pretty easy, right? Yay. All right, I've got one last problem for us. Dun 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 dun. Sometimes we might get, oh no, imaginary solutions. Imaginary? What's that? Well, remember imaginary numbers? Yeah, so we're going to deal with some of those. But it's okay. It's going to be similar to that example too. We just don't simplify all the way, or we don't get to like actual numbers. There's going to be some imaginary numbers, and that's fine. All right, so right off the bat, we have this written in standard form. So A is 7, B is 6, and C is 2. That's great. It's going to make this nice and easy for us. We don't need to rearrange anything. We can just jump right into the quadratic formula. So x equals negative b, so that's a negative 6, plus or minus the square root of b squared. B is 6, and we're squaring it, minus 4 times a is 7, times c, and c is 2. All of this is being divided by 2 times a, which was 7. All right, so take a look. That's how everything should be plugged in. It's probably the easiest place to make an error is by just plugging the numbers into the wrong spots. And then we simplify. So here we go. X equals negative 6 plus or minus the square root of 6 squared is 36. I'm looking at this negative sign. That's the only negative of those 4AC terms. So I'm just going to keep that negative there to make it easier for me. And then 4 times 7, that's 28. And then 28 times 2 is 56. And all of this is being divided by 2 times 7, which is 14. Now I'm just going to do that subtraction real quick inside the radical. So we have negative 6 plus or minus the square root. 36 minus 56 is negative 20. Uh-oh. Square root of negative 20. Can we do that? No, of course you can't take the square root of a negative number. That breaks our calculators. It doesn't exist. Oh wait, we can do that now? Oh, that's right, that's right. We can now take square roots of negative numbers. We know that that just results in an imaginary number. So, quick little sidebar again. We need to simplify this radical. So we're simplifying the square root of negative 20. I'm going to break this down first to a negative 1, right? Take that negative 1 out. We know that the square root of negative 1 is I, that imaginary number. But what else do we have? Well, 20 is the same thing as 4 times 5. So I'm just bringing it down to all three of those right off the bat. And I know that the square root of 4 is 2. And I know that the square root of negative 1 is I. So when I put this together, typically we'd write this as 2I root 5. I know, it looks crazy, right? So x equals negative 6 plus or minus, and now there's that radical that we did. Okay, this little simplification we did. The square root of negative 20 is the same thing as 2I root 5, all divided by 14. All right, now you see why I had to simplify all those radicals, right? Look how useful it is now. And then finally, our last step, we obviously can't add or subtract a negative 6 with an imaginary and irrational number, the 2I root 5. And so at this point, you just look at your three different coefficients or constants and determine if, hey, can I simplify all of these? And sure enough, yeah, just like that last one, all three of these can be divided by 2. So x is going to equal negative 3 plus or minus I root 5, all divided by 7. And this is actually how you leave your final answer, as crazy as it looks. But again, there's actually less work. So you don't have to add and then divide by 7 and then subtract and divide by 7. So sometimes it's easier when you get these. Anyways, that's all I've got for you for today's lesson. Go ahead and try the delta math. Good luck. I'll talk to you later. Bye, everybody.